Welcome to Dear SQL DBA, a podcast for SQL Server database administrators. I'm Kendra Little. It is Thanksgiving week in the United States when I am recording this podcast, and Thanksgiving in the United States is one of my very favorite holidays. I've got a lot in my life that I'm thankful for, and doing this podcast is one of them. I've learned a ton doing this podcast, both how to make a podcast as well as video processing, but also I really learned stuff from each and every question I get, even the questions that are more beginner questions. And I love getting more beginner style questions. So if you've got a question that you'd like to ask, but you're worried that it might sound dumb, don't worry about that at all. And I swear, I actually learned stuff even answering the questions that are simple. If you're enjoying the podcast as well, I would love it if you would leave me a review on iTunes. If you go to littlekendra.com and find the link for Dear SQL DBA, there's a link to where you can review the podcast in iTunes. Thank you so much if you've already left me a review. I love you. I'm really just grateful that you left me a review and took the time. That means a lot. So let's get on to today's question, which is a very fun one, because this question is the kind of question that someone asks when they're just at the space where they're learning how SQL Server runs queries, and they're just at the edge of learning really cool things about what can make queries faster and what can make queries slower. The question is, Dear SQL DBA, whenever I create a complex view, the first time I use it in a query, the query is slow. The same thing happens after I alter a view. What is the reason behind this? Well, there's a short answer to this, and the short answer is that SQL Server can use memory to make the second run of a query faster than the first run. But that doesn't tell you a whole lot. How is it using the memory and why? To find out, we need to dig into the details, and it's a much longer answer. There's really two big ways in which memory is a big deal to making your queries faster, especially on repeat runs. The first thing to know is that when you're using a view, you're really just saving metadata in the SQL Server. Here is the way that, maybe you put joins in your view. Here's the way that these tables join. And you might put where clauses in the view. You might specify a given column list, but SQL Server, it saves that off for you when you create the view. But it doesn't know how queries are going to run the view. In other words, when you write a query using a view, SQL Server doesn't know if you want all the columns. You might only want some columns. You might join that view to other tables or to other views. You might put in where clauses. So at the time you create the view, it doesn't lock itself into how it's going to execute queries that reference it. When you run a query that uses a view, it actually unpacks the view and pulls out all of the joins and the column list and all of that stuff. And it looks at what you want back, and it looks at what you're joining it to. It looks at the whole thing, right? So it doesn't treat the view as a closed box. It opens that box up and goes on in, and it looks at everything, and then it does try to simplify things where it can, depending on what you're doing with the view. And it will compile an execution plan for how to run your query. This process of compiling the execution plan can take time, and it does take time. Sometimes it's a very small amount of time, but it could be a longer amount of time. And it's a CPU intensive process. Your CPUs are an expensive resource, and you license your SQL Server by the CPUs. So it saves off your execution plan in memory so that if you run the query again, it doesn't have to do that expensive compute process. The first time we run a query, it has to compile this plan, and then it caches the plan in memory in the execution plan cache, so that if you go and run that same exact query again, it can say, hey, I put this plan in memory. I don't have to do that expensive process again. I'll just grab it from memory and go. That could save you a bunch of time depending on how long it took SQL Server to compile your plan. Well, how long does it take to compile a plan? This is usually very fast, but it varies a lot. It can vary quite a lot, but it's usually a matter of milliseconds. SQL Server is designed to try to get you a good plan, but it wants to compile that plan for you fast. The developers of SQL Server don't want you to be in a situation where you are compiling an execution plan for a minute, and then by the time it starts to run the query only takes a second. You would see that whole query is taking more than a minute when it's a really fast query. The optimizer, it doesn't look at every single way to run your query exhaustively. Even with a complex query, it will try to make educated guesses. It will see which parts of the optimization it doesn't have to do exhaustively and just try to get you a good enough plan because it wants to do that optimization in a matter of milliseconds. This means that hopefully for most of your queries, the first time it runs isn't much longer than the second time it runs. However, I have seen some queries where compiling the plan takes 5 seconds, takes 10 seconds, or even 30 seconds. And those are anomalies and are a problematic situation. The first thing to think about with this is just, okay, well, how do I measure it? If I have a query like this that's slower on first run and then faster, how do I tell how much of that is compiling? There's a few ways to do this. When you are running the query yourself, you can run in your Management Studio session, set statistics time on. When you execute that statement, you're telling SQL Server, hey, for just this session, not for the whole instance, just for me in this window, whenever I run a query, go ahead and print to the Messages tab information about parse and compile time, as well as just when queries run, how much CPU time they burn and the duration of the query. That's really, really nice because you can just run the query and you'll see in your Messages tab, if it had to compile it, how much time it took for parse and compile time. If the execution plan was in cache, it shouldn't have to do it, and you shouldn't see lots of time there. When you run a query, if you're catching execution plans, like you're running it in your session 2, you can also look for compile time in the execution plans. If you go into an execution plan and highlight the select operator at the top left of the plan, and then you have to right click and look at the properties. In the properties, it'll tell you there's an item that says compile time. That is in milliseconds, and it'll be the same time as when you're doing the set statistics time. It says for parse and compile time, it gives you CPU time and then elapsed time. So that total elapsed time for parse and compile is the same thing that you'll see in the plan. In SQL Server 2016, if you enable Query Store, and this is enabled this is available in databases in all editions, so you could do this in Standard Edition. If you turn on Query Store, it will track compile time as well as a bunch of other compilation metrics, like how much memory it needed to compile and lots of details for your queries as well. So that's a really nice option. So whenever I wonder how much of this was compile time, I will come up with a version of the query I can run in a place that's safe to run it, and use set statistics time. Or look in the plan. That's the most often things I do. Is this worse when you have a lot of joins? Like you mentioned that they're complex views. I would say sometimes. I definitely have seen cases where there's complex views that have a lot of joins and SQL Server compiles plans for them quickly. They are not always awesome plans. The more joins you get, the more ways there are that things can go wrong with a query. Now, I'm not saying they're always bad plans. I'm just saying if you think about it, you're giving the optimizer like 7 left joins and 6 inner joins and who knows what else. There's a lot of ways that can be run, and when it has to come up with that plan fast, it may or may not be an awesome plan. Sometimes when you have these complex plans, you do see long compile times, and that is unusual even for a complex query. When I do see multiple seconds of time used in compilation, I try to figure out what the cause is. One cause might just be that the time at which SQL Server was compiling that execution plan, the SQL Server may have made the query wait on a CPU resource. Figuring out how to do the plan, right? Very CPU intensive. So if all of the cores the instance can use, if they're all busy, you have to wait to get on a scheduler to figure out that plan. So the way you can tell this is to look at that time period and look at SQL Server's wait stats. If there is a notable amount of what's called SOS scheduler yield waits, that means queries were having to wait on CPU. If you have SOS scheduler yield waits and you had a long compile time, the issue may not be that the plan takes a long time to compile. The issue may just be you couldn't get started compiling it. Before I panic about this, hey, this query is very weird, I want to look at the time period when it was slow to compile. Also, perhaps where it's safe to run, compile the plan on my own and see, is it still take a long time to compile? If I've ruled that out, and I do have this query that just takes a really long time to compile, I would next look at my SQL Server patch level or version level. What service pack am I on? What cumulative update am I on? And what is available since that point? In cumulative updates and service packs, the SQL Server team periodically finds bugs where things took a really long time to compile, and they fix them. It is possible, if you have slow compile time in an area, that they have already fixed it. It is worth looking at what fixes are available, and I would set up a non-production instance on that patch, on the latest and greatest patches, and I would test the query and see if I get the same compile time or not. If I roll that out and it's just still really slow to compile, it looks like they haven't fixed it, I tend to think when compile time is taking seconds, I tend to think of that as you've hit a bug that hasn't been identified yet. I say that because they work really hard on this optimizer to make it fast so that you don't have to wait seconds. If you can report this to the SQL Server team as a connect item, they appreciate getting the feedback because they do work very hard on this optimizer. For the purpose of making your query faster, I look to see, can I simplify the query execution by adding some indexes? If I tune indexes for a query, I can simplify optimization by just giving obvious good choices. Instead of 3 things that might be okay for, one join, if there's one index that's just fantastic for it, that could simplify and change my optimization process. Similarly, I would look at the query and see if I could simplify the query. If I am using views, Are those views introducing complexity that I don't actually need in my query if I were to write it without the views? Sometimes query rewrites aren't an option depending on your application, right? But whenever you can, it's worth looking at. I would also, as a last resort, look at something like using hints in my query. I don't think hints are bad. Some folks do. I think hints are okay, but I tend to do them last because a hint is really a directive in SQL Server. You are simplifying optimization using them by taking away choices from the optimizer, and that's great when it makes your query faster. The reason I'm more hesitant to use them is that later on, if my data set changes, or even just if the optimizer changes, my hint later on might be slowing down my query when a faster option might be chosen by the optimizer at that point. Whenever I hard code hints in queries, I look at it as I'm going to have to support this later on, and that takes up my time. I would rather do things that don't have as much of a support cost later on for me because I'm lazy, and that's how I should be, right? So I don't say never use hints, I just don't do them first because they may make you take out the hint later depending on what changes. Wrapping up this first part. When you first run a query after creating a view, SQL Server has to compile a plan. It can reuse that plan as long as the plan is in the execution plan cache. Memory pressure may put it out of there. Now, what about altering the query? Altering the view was in the question. When you alter a view, you've changed something in there, and any queries that reference that view are right after you alter it, they're going to have to come up with a fresh plan. SQL Server says, hey, you're running this query, and looks like that view has changed. You know, the date on the last modified time, it has been altered since the plan was in cache view. So I'm going to generate a new plan view, and then it can be reused after that. So the alter of, and this is the same as for a stored procedure too, you're going to have to get a fresh plan after an alter. But memory is amazing in terms of reducing CPU usage on your SQL Server for frequently run queries by caching those plans for you. There's another way that memory can really make queries faster. And it doesn't fit 100% with your question, but it's probably part of it, so it's worth talking about. It takes a lot of time to read data from disk. SQL Server uses memory to cache those data pages as well in something called the buffer pool. The first time you run the query after creating the view, SQL Server it'll figure out the plan. So we go through that whole process of figuring out the plan first. When it actually starts executing the query, it will see if the pages that it needs, the data it needs, is in memory already. If you've just created the view, it's possible that the pages you need aren't in memory. Maybe they are, right? Because it's just going to keep the pages for the tables itself. It doesn't store special tables for just an ordinary view. And I'm trying to be really careful in my wording because there's a thing called indexed views that are a little different, but this is just a normal view. It will still store the pages just for the tables. So any query that uses those tables, whether it's using a view or not, can reuse that stuff in the memory in the buffer pool. But possibly the first time you run a query using the view, the pages aren't yet in memory. It has to go out to disk to get them. It has to bring them back and put them into memory and then return them. That can take a long time. The second time you run that query, if you run it again right afterwards, hey, those pages are all in my memory. I can just grab them from there and return them. I don't have to do that whole big trip to disk. For many queries, this can make a huge difference in performance and make performance much faster. When you're running a query and you want to test, hey, am I having to go read pages from disk? A really easy way to do this in your Management Studio window is to do Set Statistics IO on. So we previously talked about statistics time. This one is statistics IO. After you turn this on for your session, it'll put in that messages tab information on how many physical reads and read-ahead reads it had to do for a table. Read-ahead reads are also reading from disk. So you'll see logical reads and then physical and read-ahead reads. And if physical reads and read-ahead reads are 0, everything was in memory for that table. That means you can tell, hey, was my first run slower because it had to go do all of this physical I/O, and then my second one was faster because everything was now in memory. This means, putting this all together for testing purposes, when you're creating a new view and you want to test your query, you have a couple of different choices about how to do it. My personal preference is to test using what, I think I'm not the only one who calls it this, a warm cache. I think that's a real term. I don't think I made it up. The way I do it is I run the query the first time and I don't pay a ton of attention to the first run. I want to make sure I'm getting back correct results, yes. But I don't spend a lot of time worrying about how long it takes. I run the query a second time and then we'll look at, okay, with the data in memory, how long did it take? And I tune with the data in memory. You might want to look at, am I hitting a weird issue on that first run where the parse and compile time says something really high? That doesn't happen to me a ton, but it is worth checking. But generally, when I'm iterating and tuning the query, I tune it against a warm cache. When I'm wrapping up and I think I have everything the way I want it, I will do a cold cache test and see how long it takes there then, but I don't do it every single time. The reason I like to do it this way is that doing a cold cache test is kind of a pain. It's not necessarily a pain against a development server, but it isn't something you want to do against a production server at all, because to do a cold cache test, you need to tell SQL Server, hey, I don't want any of this data in memory. And to do that, you run a command that affects the whole instance. There's a command called dbcc drop clean buffers, which says invalidate the buffer pool. I think that's probably the right term. But essentially, everybody start reading from disk and repopulate the data cache. So if I just want to do this for testing my query, I'm going to make everybody else have to go start reading from disk too. That's not cool behavior in production. It's okay against a test instance, especially if you're the only one using it. Like if someone else is trying to measure performance and you're saying everybody's going to have to go read from disk, you could kind of mess up their day too, right? So you got to be careful. If modifications have been happening in the environment, if you're testing a whole series of things and it makes changes to data, you may also want to do a checkpoint that says SQL Server, hey, flush all the dirty buffers to the data files as well, so that it doesn't just read those out of memory too. And then for the query plans itself, you either need to use recompile hints or some version of the dbcc freeproc cache command to say, hey, I want to generate a new plan. So the cold cache testing, I have to do all of these, kind of extra commands. That's why I say testing from a cold cache is a little bit more of a drag than testing from a warm cache. You should still be careful with the warm cache test if you're reading a ton of data into memory. If you're going to be using like 50% of the buffer pool just for your testing, that could impact other queries as well as the CPU use. So even with warm cache testing, I am careful in any sort of shared environment very, very careful in production as well. But I'm kind of a bull in a china shop if I'm doing cold cache testing and I'm running DBCC drop clean buffers. All right, so that is the general take on why when I run a query the first time it might be slow, and then running it a second time it might be fast. Thank you so much for joining me for this episode of Dear SQL DBA. And for everyone who has submitted questions, thank you for the awesome questions. I really, really enjoy answering these. I'm Kendra Little, and I'll see you again next week.